Section 8.4 is about ellipses. Here you see a picture of an ellipse. An ellipse is a set of all the points in a plane such that the sum of the distance from the fixed points is constant. Now when we say the fixed points, we're talking about these 2 points here, this one at -5, 0, and this one at 5, 0. And each of these is called a focus point, and together we use the word foci. That's the plural of focus point, and so these are the 2 foci of my ellipse. These are the 2 points at which we measure distances around the outside. Now if I show you another picture, this has a bunch of information on it that helps us to understand ellipses. Every ellipse has what's called a major axis and a minor axis. The major axis in this example is the x-axis, because this ellipse is long ways, left and right, but it's shorter up and down. So that up and down axis of this ellipse is called the minor axis. There's a bunch of values that are given on this picture. We call the distance from the middle to one of the foci, we call that the C value. The distance from the middle to the endpoints along the major axis, that's the A value. And then this key concept down below kind of fills in a lot of other relationships for us. This first column is for parabolas that look like this, that are long ways left and right, while this second column is for parabolas that look like this, that are long ways up and down. Notice the difference. The x squared term is in the front, so that's a left-right ellipse, and the y squared is first in this one, so that's an up and down ellipse. It shows you which is the major axis here, horizontal, left, right. So it's going to be a wider ellipse, and this vertical axis is going to be a taller ellipse. Here are the points for the foci. The length of the major axis and the lengths of the minor axis are 2a and 2b. Now there's one other equation that you have to know that helps us build relationships with ellipses, and that's this. You'll want to make sure you write this down. C squared equals a squared minus b squared. Now that's derived from the Pythagorean theorem, but for our purposes you need to know this formula because this helps us set up a relationship of a and b for all ellipses. So in this example we want to write the equation for the ellipse that's shown here. Now if you notice, this ellipse is longer as you go up and down, so we're going to use this equation for an ellipse. That's because the y-axis is the major axis and the x-axis is the minor axis. Now to write the equation we've got to find a and b. So those are the 2 values we're going to focus on. Now if you go back to the key concept, you know that the length of the major axis is 2a. And in mine, my major axis is 12 units from 0,6 to 0,6. So in mine, 2a equals 12. Which means if you divide both sides by 2, you get a equals 6. So that's one of the values that I need. I need to find out what a is. The other thing I need is the b. Well, I don't know what the b is right now, but I do know what the c is because I'm given the 2 foci, and remember the distance from the origin to the foci, that's going to be my c. So I can see here that my c is going to be 3 units, 3 up or 3 down. So I have my a and my c. Let's use that formula that I showed you on the last page to find out what the b is. Remember I said that this formula is something we're going to have to really know because that gives us the relationship between a, b, and c. So here we go. 3 squared equals 6 squared minus b squared, and we'll solve that. So I'm going to move the b squared over here, and then I'm going to subtract 9. And so now I find out that b squared is 27. Now that's really all we need to know, because with b squared being 27, I know my a is 6, which means my a squared is 36. I can now make my equation. A squared is 36. I just found out that my b squared is 27, and that equals 1. So this is all I need to find out the equation of this parabola with a y of a major axis. Okay, let's do this again and find another equation of an ellipse. This time my ellipse has a major axis on the x-axis, which means my equation is going to fit this form. So I've got to find my a and b. Again, my a is the distance from the endpoints here on the major axis So 2a is 12, which again, a is 6, which means my a squared is 36, and that's one of the first things you need to find. Now we know the foci here are at 4 and -4, so I know c is 4, which makes c squared 16. Now why is that important? Because I can use my relationship c squared equals a squared minus b squared to find out the b that I don't know. So plugging in my c squared and a squared, I'm going to add the b squared to get it over here. Then I'm going to subtract 16, so make this a 20. So that means my b squared is a 20. So now I know a squared, I know b squared, I can write my equation. So here you have two equations for an ellipse that's at the center, at the origin, and you notice it just has x and y. But there is a possibility that you could translate an ellipse up, down, left, and right, in which case you have an h and a k, which is your translation. So here's what an ellipse would look like if it was not at the origin. Still has a horizontal or a vertical axis, a major axis, and now the foci are a little bit different, so make a note of that. So then we have an example here that gives us an equation, and now we've got to find the center, the foci, the lengths of the major and minor axis, and then finally graph it. Well, because of a general form of an ellipse, we know that a squared is 16. So by taking the square root of both sides, we can see that a is a 4. We also know that b squared is 4, and by taking the square root of both sides, we know that b is 2. Because of our relationship c squared equals a squared minus b squared, I can find the value of c. So c squared equals 16 minus 4. So c squared equals 12. If I take the square root of both sides, I get a 12. Then if I simplify that, I'll take out square root of 4. And so c is going to equal 2 root 3. That's an important value because that helps me find my foci. So in fact, I know that my foci are at 2 root 3 comma 0. That's one of the points. And negative 2 root 3 comma 0. Those are my two foci points. And I know that they're the x values because I know this parabola is wider than it is taller because that's the major axis, the x-axis. So here's the foci values. The center of this parabola we know is at the origin 0, 0. Because it has no h and k to adjust it. I know that my a is 4, so my major axis has a length of 8 units. And the b is 2, so my minor axis has a length of 4 units. So those are the four major things that we need to find out from this equation, and now we'll graph this. We know the center is at 0, 0. I know I'm going to go 4 to the right and 4 to the left, because that's the major axis. I'll go up 2 and then down 2. And you should be able to do a decent sketch of the ellipse. It should look like that. Here's another example. I have to find the center, the foci, the length of the major and minor axis, and then finally graph it. However, this one is not in the standard form for an ellipse, so I'm going to use the completing of squares to get it into standard form. So I'm going to group all the x's together, leave a space. The 4y squared minus 24y, again leave that space. And then I'm going to move the 24 by subtracting it to the other side. Now I'm going to complete the square. I'm going to find the value that goes here, and find the value that goes here, and makes perfect square trinomials. So half of b is 2. Square that, so I'm going to add 4. To officially complete the square, you have to have a leading coefficient of a 1. So I'm going to factor a 4 out and make this a minus 6y. And now I'm going to complete the square here by taking half of 3, squaring that, which would be half of 6, which is 3, squaring that, getting a 9. Now I'm not going to add 9 to this side. Instead I'm going to add 9 times 4, because this is really a 9, but the 4 on the outside makes it a 36. So I'm going to add 36 to this side. And let's see how everything simplifies now. I have a trinomial here that can factor to be x squared plus 2, or excuse me, x plus 2 squared. There we go. This one, I pull the 4 out, and my trinomial factors to be a y minus 3 with a square. And then over here, I got negative 24 plus 4 is negative 20, plus 36 is 16. Now this is still not quite in standard form because I need to divide by something that makes this side a 1, because every ellipse is equal to 1. So I'm going to divide everything by 16. So this is now the proper form for an ellipse for this equation here, but it's written in the way that we can take the information out. So now I can see that my a squared is 16, which means my a is 4. I can see that my b squared is 4, which means my b is 2. Using my relationship c squared equals a squared minus b squared, I can find out what c is. So a squared is 16, b squared is 4. So c squared is 12, which we take the square root again, and it's going to be 2 root 3 when we simplify that. So this is actually just like the last example. It has the same foci, except the origin of my ellipse is not at 0, 0. In this case, and I'll slide this down a little bit, the center of my ellipse is at negative 2, 3, because that's the h and the k that I get when I look at the general form. Now my foci would be at 2 root 3 if it was at the origin, but it's not. It's translated with a minus 2. So my two foci points are negative 2 minus 2 root 3, 0, and negative 2 plus 2 root 3, 0. Now just like in the previous slide, we know the major axis is 8 units. And the minor axis is still 4 units. And we can use that information to graph it. So now my center this time is at negative 2, 3. So that's the translation. But I'm going to go 4 units to the right for the major axis and 2 units up for the minor axis. So it's the same parabola I had before, just translated. There you go.